Hey folks, how's it going? My name's Peter Hansons. Welcome. Happy New Year to everyone. Hope you're all doing really well. Before we dive in, thanks so much for joining us. I'd be keen to just, find out where you're all dialing in from. But given this is not always the most interactive way to communicate, via these LinkedIn Live webinars. I might just get this show underway. Do let us know in the comments if you can't hear us or it's difficult to read anything. Definitely keen to make sure that you can engage with this content as best as possible. If there's any dramas, we'll probably redo this at a later date just to make sure that it all comes through crystal clear. It's been a couple of years since I last did my last live stream. It was, I used to do a lot of it during the COVID days, those good old days. But then sort of once we could meet up in person again, I sort of kind of gave it all up and, got into that. But sounds like live streams and podcasts are really sort of making a comeback this year. So I thought I'd give it a shot as well. So let's just see how it all plays out. Hopefully it plays out well. I'll just check. Looks like LinkedIn is all working fine. So we might actually get this party started. I will share my screen just so that you make sure that you're in the right spot. Basically here to take you through, well, let me take it from the top. Welcome everybody. Today we're going to dive into how you can build a scalable and cost-effective data lake using Apache Iceberg on AWS. This session is particularly focused on startups and growing companies who want to implement robust data infrastructure without breaking the bank. I think that's probably most of us these days at the moment, especially in this economy. Before we dive in, a quick introduction. I'm Peter Hansons, founder of Cloud Shuttle, a homegrown Australian data engineering consultancy. We work closely with fast-growing companies to implement practical and cost-effective data engineering solutions. I've been doing this for over a decade, seeing both what works and what pitfalls to avoid. So hopefully, you can benefit from that experience. So let's quickly cover what you'll need to follow along for this webinar. You should have basic Python knowledge, nothing too advanced, just enough to understand the code examples. You'll need an AWS account to access, to implement these solutions, and a basic understanding of data warehousing concepts. Don't worry if you're not an expert in all these areas. We'll explain the key concepts as we go. Here's a quick overview of our introduction section. So we'll be covering these three main themes just real quickly to give you a bit of a primer. Let's start with the challenges most startups face with their data lakes. We commonly see issues with rapid data growth, overwhelming existing systems, schema evolution becoming a nightmare, and the constant struggle between query performance and costs. These are exactly the problems that Apache Iceberg was designed to solve. Iceberg is a game changer for three main reasons. First, it brings ACID transactions to your data lake, meaning your data stays consistent during updates. Second, it handles schema evolution seamlessly, no more breaking changes. And third, it gives you time travel capabilities. Imagine being able to query your data as it existed at any point in time. Just going to really quickly just pause there and triple check that the screen's coming through fine. It's not too small on everyone's screen, but it does look like it's working fine. So that's cool. So we'll be using a powerful combination of tools: AWS S3, our storage foundation, AWS Glue, our data catalog, and Mage AI for building our data pipelines, and PyIceberg for interacting with our Iceberg tables. This stack gives us everything we need for a production-ready implementation. Here's our roadmap for today's session. We'll follow a practical, hands-on approach broken into 4 key sections. We'll start with the architecture fundamentals, then dive deep into actual implementation with real code examples. The third section focuses on maximizing your return on investment through optimization techniques. Finally, we'll wrap up with concrete takeaways you can apply immediately. This isn't just theory. Everything we'll cover comes from real-world implementations we've done with startups just like yours. Feel free to ask questions throughout as we build this knowledge progressively. So that concludes the intro, and now on to the architecture overview. Let's look at how Iceberg and AWS work together. On the left, we have Iceberg's core components, managing metadata, table formats, and data organization. On the right, AWS services provide the scalable infrastructure. Together, they deliver the balance of performance, scale, and cost efficiency for growing companies. Iceberg's power comes from its layered architecture. Starting from the bottom, we have data files in Parquet format, manifest tracking these files, snapshots for versioning, and table metadata at the top. This separation is what enables atomic updates, schema evolution, and fast queries. Evolution from traditional formats, table formats, are key differentiators, immutable files for atomic updates. They separate metadata and data layers and snapshot isolation. Cool, so let's understand how ACID transactions work in Iceberg. As you can see in the diagram, the process flows from our initial state through to commit, with each stage ensuring data integrity. We require locks, validate changes, ensure serialization, and persist all atomically. This guarantees your data stays consistent, even during concurrent operations, a critical feature for growing data lakes. Schema evolution is a standout feature of Iceberg. As shown here, you can safely add columns, promote data types like int to long, and reorder columns, all without breaking existing queries. This is game-changing for fast-moving teams who need to adapt their data models frequently while maintaining system reliability. The AWS integration is built in 3 layers, S3 at the bottom for storage, Glue Data Catalog in the middle for metadata management, and various query engines at the top. You can see a couple of different AWS services. You could potentially even use DuckDB and other types of query engines. So this gives you flexibility on how you can access and process your data, from batch processing with EMR to serverless queries with Athena. Each layer is optimized for its specific role while working together seamlessly. Here's our recommended S3 bucket structure for Iceberg implementations. Notice we separate production and development environments, maintain clear paths for data, metadata, and lifecycle management. The key is using appropriate storage classes, hot data in standard, aging data in Glacier, with clear lifecycle rules managing transitions. This structure ensures both performance and cost efficiency. AWS Glue Data Catalog serves as the central control plane for our Iceberg implementation. It manages 3 critical aspects: table metadata for tracking locations and versions, schema registry for data type management, and partition handling for query optimization. The beauty is that it integrates seamlessly with AWS controls, allowing fine-grained access management across your organization. Security is implemented in layers, network controls at the perimeter, IAM for access management, and encryption for data protection. You have 3 encryption options: SSE S3 for simplicity, SSE KMS for more control, or client-side for maximum security. we recommend starting with SSES3 and evolving based on your security requirements. Okay, let's dive into the implementation deep dive. So we'll use Mage.ai as our processing engine to handle data loading and transformations, with Apache Iceberg managing our table operations. We're actually going to use AWS Wrangler instead of Apache Iceberg in this particular demo, just because it helps a little bit with our table creation and the like. So please bear with us with that. The pipeline, but typically we would use Apache Iceberg normally because we've got all the tables set up, but all good. So the pipeline flow is straightforward from source systems through Mage AI for processing, and finally in our Iceberg tables. We'll build this step using Python, AWS SDK, and modern data tools. Here's a simple Mage AI pipeline. We have three key components: a data loader to read from S3, a transformer to clean the data, and an exporter to write to our Iceberg table. What makes this powerful is Mage's declarative style. Each component is self-contained and reusable, making our pipelines easy to maintain and modify. Here's the first step in our Apache Iceberg setup: initializing the catalog and creating our namespace. Notice we're connecting to AWS Glue and our catalog and specifying our S3 location. This foundation allows us to maintain a clean separation between storage and metadata, which is crucial for performance. And here's where we define our table schema and create our first Iceberg table. Note how we're using Apache Iceberg's type system to explicitly define our columns: ID as long, timestamp for time tracking, and customer ID as string. This explicit typing is crucial for maintaining data quality and enabling schema evolution later on. Here's our loading process using Iceberg. We first convert our data to Apache Arrow format for better performance, then load it directly into our Iceberg table. Using Arrow as an intermediate format gives us better memory efficiency and faster write speeds compared to traditional data frame operations. It's a key optimization for handling larger data sets. So here's the schema evolution in action. Watch how we can add new columns, rename existing ones, and even update column types, all while maintaining data consistency. Each change is atomic and requires an explicit commit. The beauty is that existing queries continue to work, making this perfect for evolving applications without downtime. Awesome. So before we dive into our cost optimization and best practices, we might just go ahead and do a demo. Let me just actually see if I'm doing the demo. Yes, let's just do the demo now, I think. And I'll just check my notes just to make sure that we're good to go. So 1 second. Let me check. Awesome. So I'll just bring up my Mage cluster and then we'll start diving into the demo. How does that sound? Hopefully that's very exciting. All right. Cool. So this is our Mage environment. I might just try and change the screen setup so that you can see everything a bit bigger. I'll click on new pipeline to create a new pipeline, and then I'll start from scratch and do a batch one. Oh gosh, my screen. Okay, I'll create that new pipeline. Cool. So first of all, we need a loader block, as you'd imagine. So I'll just click on the Python API. I'm not going to do live coding for you right now because I'm a scaredy cat. So I'm just going to copy past a bunch of SQL Python that I've already got ready to go, pre-canned, something that I've prepared earlier. So I'm just going to paste this in and just sort of take you through exactly what's going on. Cool. So basically we're just importing requests and polars. We're fetching some data from Open Weather Map, getting some weather information from these various different cities. They've got specific lat longs, and loading that data into a data frame. So what we'll do to kick that off is we'll just press the run button, see how that goes. This is kind of like a Jupyter Notebook setup. Looks like that has failed. That's no good. Let's see what's the matter there. Let me just see. Might have a little bit of issue with our code, but let me just try and debug this live. I was hoping to avoid having to debug live, but here we are. Let me just make sure that I've got all the stuff correctly ready to go. Let's just see what we can do. Indent doesn't match. Okay, Python doesn't. Okey-dokey. Let's just see whether this fixing the indent will get us. Let me just see what else we can fix. This may turn out to be a bit of a fail. Okay, that worked. Wow. New. Okay, so we've only got one column here though, which is a bit of a shame. Let me just try that again. That should have returned at least, 5 cities. We've got Sydney, Brisbane, Perth, Gold Coast, and Alice Springs. But okay, we've got. that's the test output. Okay, so that's cool. All right, so basically we've got we've read some data using this this Jupyter Notebook interface, and basically we've read all of these columns. Now what we want to do is we want to do add another block, which is a transformer block. So we'll just use the base template generic. And add this transformer block. So what we just did there was we loaded some data from a data source, and then we're going to now do a bit of a transform of that data. Just some of the data in the previous step isn't quite as usable as we'd like. I can explain why. Say, for instance, this temperature is 295.98. If that was in Celsius, that would be pretty damn hot. So obviously we want to see if we can get that in Celsius. I believe that's in Kelvin. So we need to do some adjustments, some unit conversion on that temperature value there to convert it to Celsius. because we are in Australia and we use temperature conversion. 1 second, I've just lost my screen. I'll just fix that up for you. Cool, going back to the screen. Okay, so I've pasted in this this transformer. We've got a couple of things going on here. So basically, all we're going to do is we're going to add the observation time, which is just basically getting the time as of now, and then we're just going to do this temperature conversion. All right, I'll go ahead and execute this. And that failed as well, probably because we were editing everything in a document, and it just doesn't like the indentation and stuff like that. So we're going to fix this up. Cool. Live demos, hey? But where it is? Okay, data frame with columns, unexpected indent. All right. We can get rid of quite a few of these comments. My apologies. This is why no one does live demos anymore these days. It's just too scary. Okay, that seemed to have worked. All right. And that temperature is looking a lot better now. So we've got, 22.83 degrees, which kind of looks like more of a Sydney temperature. And then we've got the observation time being the 9th of January 2025. And I think that's the date today if you're joining us from Australia, if you're in our current time zones. That's all really good. Cool. All right, let's move on to the exporter step. So basically, we fetched some data from an API. We've transformed it by adding a couple of columns, like or converting the temperature to Celsius from Kelvin, and then adding the observation time. So done a little bit of data transformation there. Cool. All right, and so now that we've done all of that, we want to basically just load that data into Iceberg. So let's go copy and paste some code for that. So I'll go ahead and grab that step 3 code. And I will add an exporter block here. Okay, and we'll just use the base template generic. It creates this really cool name called Billowing Moon. Awesome. And then I'll just copy in this code. And it's, I dare say that we're going to have, what's the name? Just update the name to call it Peter Hansen's V2, and I might need to fix up some indentation issues, so let's just have a look. So basically we're using AWS Wrangler here, Beta 3, which is probably familiar if you've interfaced with AWS Pythonically, and Polar's efficient data frame. And then I probably just want to go ahead and just fix up some of these indentation issues before it complains at me. Here. Okey-dokey. That all looks pretty good. Let me just see if we can get this working. So basically what this is trying to do is, I've just set this variable, which is my name. Got a few underscores in there. I've got a database in the Glue data catalog called CS_workshop_weather. Table name is daily weather underscore this variable, my name. And then we've got this S3 path. And then setting the region, of course, where the bucket's stored to the Sydney AWS region. And then using Wrangler and Athena, just creating this Iceberg table and loading all of this data up, hopefully successfully. If this doesn't give me any further indentation issues. Takes a little bit of a while because Wrangler's doing a lot of things under the hood, just creating tables and inserting the data and all the rest. Okay, managed to get it done in 14 seconds, so that's all good. So Iceberg tables created and all the rest, but I guess you can't really see that, so probably should try and prove that to you. So we'll just run a query against that to fetch the Iceberg data out of Athena. Cool, so I'm just going to grab a bit more custom code. I'm gonna write a custom Python block here. And while I'm doing this, I hope you kind of can see the benefits of using something like Mage AI, because effectively I'm just stepping through with the Jupyter Notebook interface, and building like a data pipeline, a DAG of steps where I can do various data transforms, load up, export this data to Iceberg and stuff like that, and just step through, I guess, all of the logic. And like if I've got some issues, as you can see, I had some indentation issues, and I was able to just quickly fix them up and troubleshoot whatever I needed to troubleshoot, and Bob's your uncle. And and that's pretty much what we've got here, is that really easy to use interface, single pane of glass, and able to troubleshoot issues even on a live stream, with the stress levels pretty high up there, but managing to get through it. So, and I think that's kind of one of the benefits of Iceberg and Mage, and this whole solution that we've put together. I wouldn't say that it's the only reason why it's good, but I think there's definitely sort of like lots of benefits of developing your data pipelines in this way, and we can go through them. Keen to get your questions and feedback on this session, but we can go through sort of other reasons why this is quite a good solution. But let's just see. Can't see any sort of glaringly obvious indentation issues on this one, so I'm just gonna YOLO it, and we'll see whether this works. Cool, so we've got that record back. We probably would want to load in more than one record next time, but anyway, I didn't want to go to the trouble of trying to debug and slow us down on this live stream. But obviously Iceberg's not your typical storage table format for just a single record. It usually, it's more used to sort of loading up millions of records at a time. But this is just a bit of a contrived example as to how you can sort of get up and running with Mage and Iceberg and building data pipelines fairly easily with let's face it, a bit of a contrived example. But yeah, so here we go. We've basically got using AWS Wrangler again, I believe. We've sort of run a select statement against Amazon Athena, selecting a couple of columns from this particular table that we created earlier, and it's returned a result set. So that's how easy you can interface with this. 8.4 seconds to return this data. Probably not blowing anyone away in terms of performance, but definitely I think in terms of its cost, it's definitely pretty amazing. And I think for the right use cases, this can be a very powerful tool set to do sort of large scale data processing. So yeah, keen to hear your thoughts. Okay, let's just switch back. Sorry, I've had that "where are you dialing in from" thing down the bottom for all this time. I should have picked up on that earlier, but definitely keen to find out where you are dialing in from, though. So cool. Now let's get back to the slides. Let me just fix this up. What are your thoughts on the Mage interface as well? Any comments, feedback on the Mage interface? I think it's pretty slick. I'd like to meet their UI designer. I think it's they've done a fantastic job, if you ask me. But yeah. Bear with me, just getting back the screen. Awesome. Cool. All right. Thanks so much for your patience. So that pretty much concludes our demos. Like I said, we got some data from our weather API, did a few transformations. And then loaded it in, exported the data into Iceberg, and then queried it using the same Mage interface. So we had 4 blocks. They've got some really cool different ways to sort of use that sort of block interface and stuff like that, using dynamic blocks and the like. So we can dive into some of those particular things at a later date. But yeah, that's basically some of the core I guess ideas around Mage. Is you've got these 3 blocks, a loader block, a transformer block, and an exporter block. And then you can do some sort of custom blocks and stuff like that as well. So hopefully that all makes sense, and you got to see how easy it is to work with Iceberg as well. Cool. So cost optimizations and best practices. Let's talk about this strategically. Think of this as a pyramid. Think of this pyramid as your roadmap. Start with the foundation, infrastructure choices, and basic data organization. As your needs grow, move up to query optimization and maintenance. The key is to implement each layer well before moving to the next. This prevents premature optimization while ensuring cost effectiveness at every stage. File size matters more than you might think. We found the sweet spot is between 128 meg and 512 meg. So definitely not a single line of weather data is basically the TLDR. So small enough for quick reads, but large enough for efficient processing. Notice how metadata overhead, the dotted line, increases with smaller files, while query performance, solid line, plateaus after a point. We'll set up automated maintenance to keep your files in its optimal range. So also there's a new service that AWS has released called S3 tables. So we didn't talk about that today because it's not available in Sydney and yet, I don't believe. And I think Pi Iceberg support's coming soon, but also S3 tables can do a lot in this regard in terms of the small file issue with Iceberg. So here's your query optimization toolkit. Start with partition pruning to skip unnecessary files. Use Z auto clustering for multi-dimensional queries. Leverage statistics for smarter execution plans, and push down predicates. Push predicates down for early filtering. The key is combining these techniques. For example, using hidden partitioning with statistics can dramatically reduce your scan times and costs. Let's learn from others' mistakes. The 4 biggest pitfalls we see are over-partitioning that kills performance, the small files problem hurts costs, poor schema design complicates queries, and skipped maintenance leads to degradation. Each has a solution. Each has a clear solution. Use hidden partitioning, regular compaction, normalized schemas, and automated maintenance. Prevention is always cheaper than a cure. Here's what a typical Iceberg implementation costs breakdown to. So 35% of the cost is storage, 25% compute, 20% data transfer, and 15% maintenance. The total cost typically ranges from $25 to $35 per terabyte per month. The good news, each component is optimizable, from using appropriate storage tiers to optimizing query patterns and automating maintenance tasks. Focus on the biggest slices first for maximum impact. So that cost profile for storing your data in Iceberg is pretty amazing. So let's compare total costs across popular options. Iceberg comes in at $100,000 annually per 100 terabytes. Note, lower than Hive at $150,000 and Delta Lake at $125,000. But look beyond just costs. Iceberg gives you ACID transactions, seamless schema evolution, and time travel capabilities. With lower maintenance overhead, it's about getting the most value for your investment. Here's your 12-month implementation strategy roadmap. Start with quick wins like data compression and regular cleanup in the first 6 months. Then move on to advanced optimizations like clustering and automated maintenance. Following this path, we typically see 30 to 40% cost reductions, 50% faster queries, and 70% less manual maintenance work. It's about making steady, sustainable improvements rather than trying everything at once. So the key takeaways for today, let's focus on the 4 pillars of success with Iceberg. So it's core benefits of ACID transaction and schema evolution, a methodical implementation approach with strategy, cost optimization through right-sized files and appropriate storage tiers, and best practices centered on automation and monitoring. Remember, start simple, automate early, and scale gradually. If you take away nothing else today, remember this: Iceberg isn't just about features or cost savings. It's about building a data platform that can grow with your business while staying manageable and cost effective. So thank you so much. It's been an absolute pleasure spending, 40 minutes with you today. Hopefully this has been informative, that you have learned a couple of things and got you thinking about where you can take your data platform. And with that, any questions? I'll check the live stream and just see if we've got any live questions. Saying that there's music in the background. Okay, I'm not too sure, but I'll see. Yeah, I'm not too sure whether there is some live music, but we'll have to look. I do apologize if there was some live music. If that's the case, we'll see if we can do another podcast a webinar in the future where we can remove it. Sounds like that's probably all the sort of feedback that we've got through. I think this recording is going to stay up on LinkedIn for a while. Please just comment on this recording and send us any questions or thoughts that you've got for content that we can produce at a later date. Definitely keen to make sure that we can make this as informative as we possibly can, and take you through any sort of questions that you've got with regards to, say, using Mage and Iceberg. We might do further sort of podcasts and webinars also around ClickHouse and using and loading data from Confluent into ClickHouse, doing real-time analytics, and potentially using Mage in a Flink-like capacity to load data into ClickHouse. So sounds awesome. Thanks so much for your time. Please do send through your feedback, and we're actually running these workshops on Mage and Iceberg across Australia and New Zealand over the next 12 months. So do reach out to us and we'll let you know where the nearest one is for you. All right. Thank you. Thanks once again. Cheers. My name is Peter Ansons. Chat soon. Bye.